welcome back everyone, welcome back. I'll take attendance here in a second. The piece of paper I'm going to hand you, you're going to put your name on it, put the period on it. We're going to do our little in-class activity. We're going to do it first. I want you to put everything down below you except for your pencil. And if you're setting it for lunch, do that, take care of it. Get rid of it as soon as you possibly can. I have no idea how many clicks and stuff it takes to do that. Is there two there, or did I give you one? Okay, so I'll let you get set up here. Name on it, period on it. Mine here.
Yeah, mine's here. She walked out the door already.
What does she want? Bathroom? Everyone else is here. She didn't say she was going to the bathroom to me, did she? I just totally ignored her.
I don't know. I was coming in the door and she left.
Okay. Hope I didn't ignore her. Apologies if I did. All right. Let's get the volume of stuff. All right. I know it's going to seem a little odd what I'm about to pull here. All right. Can you guys see that okay? Okay, so you need a little piece of paper, put your name on it. Okay, I want you to number the paper 1 through 12. 1 through 12, as you can see there. 1 through 12. That is a wide feed from my desk, as you can tell. Alright, so here's what we're going to do today. I thought this would be kind of fun. It's not a quiz, so don't calm yourself. I just want to see how well you can kind of pick out the names of the three-dimensional shapes. So what I'm going to do with my live feed, I'm going to put the shape down on the little like number where it's at, and you have to name it. Does that make sense? So the different types of polyhedron, so three-dimensional objects. So it could be a type of prism, could be a pyramid, could be a conic of some type, you know, like a cylinder, sphere, cone. I want to see how well you know your names, okay? So we're going to have 12 problems. The last two are going to be really big. So just kind of be mentally prepared. The last two are going to be really big objects. I don't even know if I can back up my camera far enough so you can see it. Okay, are we ready to go? Everyone's got it numbered 1 through 12 in your little piece of paper. All you have to do is tell me the name. Try your best at spelling, but I know it can be a little rough. Okay, here we go. So number 1, I'll hold it up in front of the camera, then I'll place it. And I'm gonna leave those there. All right, so number 1, here you go. Here's the first shape that you have. That's number 1. Again, I'll move it around if you need to see it again. Okay, it's number 1. Number 2. There's number 2. Number 3. That's number 3. I'm not worried about that one. It's going to stay on the paper. We're just going to put that. So that was what number? That was number 3. Let's place it over here. There we go. All right, number 4. Okay. That was number 4. Okay. Do you want me to hold up any of those 4 one more time so you can see them a little bit better? Okay, 1, 2, 3, and 4. Okay, number 5. It's number 5. We ready to go? Number 6. There's number 6. Number 7. Number 7. Okay. Number 8. I'm going to hold that there just for a few seconds so you can see that. It's number 8. Number 9. Number 10. So I'll let you count that. And I'll hold up there so you can see that. It's 10. Okay, now, the last 2. I warn you, these are kind of big. Alright. So this one's kind of big. Alright, number 11. I broke it the other day. I dropped it. So ignore the top. There's number 11. It's kind of large. See where I dropped it when I was picking it up. Yeah, that's number 11. Okay. And number 12. Okay. All right, does anyone want me to zoom in the camera on any specific shape? 1 through 12? Okay. Okay. So let's talk about them. Okay, all right. So, What do we have? What's number one? Let's talk about that first. What do we have for number one? Number one's right here. What is this object? Is it a prism, pyramid? Is it some type of conic? What are we looking at? What are you thinking? Please.
Is it a square prism?
Okay, it is a prism. You could call it a square. I'd probably call it a rectangular prism. That's the correct term. I agree with you. The squares are probably the parallel, but just probably the correct term that we'll call it a rectangular prism. So rectangular prism. Now, what makes it a prism? The two walls that are parallel are the same shape. So yeah, I could understand why you said square, because the top and bottom are squares. Right? Probably the correct term would be rectangular. Okay? All right, number two. What do we have there?
Pyramid.
What type of pyramid?
Square pyramid.
Square pyramid or rectangular pyramid. The reason why, the bottom was a rectangle. It actually had four sides to it. So this is a rectangular pyramid. Now, what makes it a pyramid and not a prism? Let's talk about that.
It's the points at the top, isn't it?
Point at the top, one point at the top. That's what automatically makes it a pyramid, not a prism. Okay? Okay, good. Now notice, I didn't say square, I said rectangular. Even for that top one, I'd probably agree with you. You know, the bottoms were squares, but they just call them rectangles. Okay, a square is a rectangle. Okay? Number three, it's this one right here on my mask. What do you got?
Sphere.
Sphere, okay. Yep. That one's probably the easiest one. Little ball. Sphere, right? Four,
Cube.
cube. That's the correct term. There's another correct term you could have called it. There's another term we could have called it. There's actually two more that you could have called it.
Could it be a prism?
Say it again.
Could it be a prism?
It could be a prism. What type?
Rectangular.
Rectangular prism again. So you could call it that. I'd accept that. And there's another term you could have called it. So I'd accept in any of these three. What's the last term? It's one of the platonic solids. How many walls does it have? How many faces? Say it?
6.
It has 6. So we'd say it's a hexahedron. Hexahedron. Or another fancy way of saying a cube. Okay? All right, very nice. I'd probably call it a cube myself, but I like rectangular prism. I like the hexahedron if you understood that's exactly the shape it was. Okay? All right. Are we good on the first 4? Again, don't worry if you got it wrong or right. This is to get practice. I want you to get better at this so when you get to the test, you can identify that shape. Because on the test, it'll be very similar to this in some questions. Okay, number 5. What are we looking at?
Triangular prism.
It is a triangular prism. It's not a pyramid. Let's define this wide. So this is a triangular prism. Triangular prism. Why is it different? Why is it not a pyramid?
Because all the lines don't go to one point.
Exactly. No matter which way I turn that, the top will never go to a single point. There's always more than one point at the top. Like right now, there's 3. But if I turn it, there'll still be 2 points on the top, 2 vertices. So it's not a pyramid, right? No matter how you look at it, it looks like a tent if you were to turn on the side. Okay? And again, we name it triangular prism because it's got triangles for the 2 bases that are parallel, and it's got rectangles that connect it. So, all right, good. 6. Cylinder. Yeah. It's a cylinder. It's got circles top and bottom. It's got that smooth curved shaft that connects them. Okay, now 7. 7 is a little deceiving where you're seeing it right now.
It's a pyramid.
It's a type of pyramid.
Triangular.
Triangular. It did have a triangle on the bottom. I tried to hold that up when I was spinning it. So It is a triangular pyramid. Triangular pyramid. Nice. All right, now comes the tough ones. I consider probably 8 and 10 probably the more challenging ones. 8. What? Say it again.
Octagonal.
Octagonal prism. Yeah, it's an octagon on the top. It's a stop sign. There's 8 walls. I tried to hold it there as long as I could. That is an octagon on the top. There's 8 walls on the top, 8 edges, I should say. So it is an octagonal prism. Octagonal prism. And what makes it a prism? It's got rectangles that connect the 2 parallel walls. It's not a pyramid. Okay. Okay, we good with the next 4? How you doing so far? We missed too many? Yeah? Okay, fine. We'll get better with this.
Well, I think it's just misunderstood what we're doing.
Oh, all you have to do is name it. That's all I need. Huh? 9, what do we got? Cone. Okay. 9's cone. Okay, it's got a singularity at the top. It's got the circle base, smooth shaft that connects it. I was a little worried that looked like a triangle when I was holding it up. I was trying to show, like when I spun it, it was very smooth. Because it does look like almost like a pyramid. Okay, 10, another challenging one. What'd you say?
Hexagonal prism.
Hexagonal prism, yeah. It's got a hexagon on the top. I was trying to hold it up so you could see that, so you could count. So it's a hexagonal prism. Again, it's a prism because it's got the rectangles that connect the 2 parallel walls together. Okay. All right, now 11. It was that big green looking thing. It's still on my desk. You can probably see it from where you're at. Probably didn't even need to look at the camera. What is that object?
Triangular pyramid.
Yeah, it's a triangular prism. Okay. Or triangular, not prism, but pyramid. Yeah. So it's got the triangle on the base, and it goes up to a singularity at the top. It's only got 1 point at the top, so it had to be a pyramid. So it was a triangular pyramid. So that was a lot like number 7. So 7 and 11 have the same name. So triangular pyramid. Okay. Okay. What about 12? 12 is that other weird looking shape. That one. What do you think?
It confuses me.
I know, right? It is confusing when you first look at it because it doesn't look normal.
Triangular pyramid.
Yeah, it's a triangular pyramid again. It's got a triangle for a base, and it only goes up to a singularity at the top. It's still a pyramid. They just took the point and drug it to the side, and really confuses you. It is a triangular pyramid, just they don't have the point at the very center of the object. They pushed it off to the side. So that was that's probably the 3rd hardest problem that you had. It's hard to see that one. It's just not. Yeah, it's not a normal look to a pyramid that you'd probably expect. So, all right. I thought there was kind of an interesting way to do it. So it's one of those things. I think we just need to get practice at some of the words on the vocab on the test. Obviously, we have all the types of polygons, right? We have quadrilaterals and hexagons and dodecagons. But then a part of the test will be 3-dimensional shapes. So maybe in the part of the vocab section, it'll have a picture instead of a description. And so you have to look at the picture and see, okay, what shape am I looking at? That was something I was exploring for this next test. So the vocab will be a little bit more spaced. It might take the whole first page. It'll be about 12 to 13 problems again. But some of them might be actual pictures, and you have to go pick out which one it is. So I thought this was kind of an interesting way to do it. The only hard part about doing that is if it's a 3-dimensional object, it's really hard to see that when it's printed on a flat piece of paper. So it might be one of those things like during the testing, I'll hold up the object. Be like, hey, this is number 4 on the vocab, like what you're seeing here. So you can kind of see like a 3-dimensional object of it. Okay, questions? Perfect, okay. So what we're gonna do today, I'm gonna put the formulas on the board, so I'm gonna get rid of these. I'm gonna put the formulas on the board that you need today. We have 2 slides that we need to go through. It's actually only 1 slide technically, but I'm gonna show a second slide. There's a slide that I need to have in your notes today. I'm gonna walk around and collect these little pieces of paper as you get your notes out. So you can just leave that little piece of paper where it's at. Okay. put your names on it. Okay. Okay, so here is our PowerPoint today. So we need rid of these words. So number 8, or 1 the section.
Is there no shape on your desk?
What was that? Yeah, there's more. The container came in. Okay. All right. Okay, so section 1.8, the last formula we have to talk about today. We have to talk about the volume and surface area. I'm just going to intro this today. I want you to get it in your notes somewhere, and we're going to talk about it, and then Monday we're going to really practice it, okay? This is one of the last sections that we have to really cover that has major formulas in it, okay? All right, so let's talk about surface area, the definition of it, what surface area is, right? We talked about area. So what do we know about, polygons and area? How would you define area to somebody?
It's the space
Yeah,
in
space.
between the border of the shape.
Yeah, it's the space in between, right? But what is the number we describe it as, right? It's the number of squares on the object, right? So it's the space in the inside, but it's the number of square little tiles you can put on the surface. So this room has an area, right? You can see it. It's on the floor. You can see the little tiles. But on a three-dimensional object, they call it surface area. It's the area on every surface of your object, wherever that's at. So you have to calculate all of it. So it's a two-dimensional measurement of the area of each face or each surface of that solid figure. So it's a two-dimensional measurement of the surface of that solid. So that's why I said there was going to be a second slide. Technically, I'm going to put the slide back up there that we had the other day where it had all the area formulas. Because you need to know the area for a triangle, area for a rectangle, area for a circle, because those are going to be important. But when you do a three-dimensional, you have to find the area of each individual side by itself. Once you find all the areas of each wall, then you add them all up. So it's the sum of all the surfaces. Okay. Again, it's the sum of all the areas for each surface or each face. Sum means to add. Okay, now, the second word on the board here is volume. How would you describe volume to something? To someone? Please.
The space inside a three-dimensional
Yeah.
area.
So it's not two-dimensional, it's three-dimensional. So what I described earlier, so in this room, if you talk about area, it's the tiles on the floor, right? It's how many little tiles could fit. In a three-dimensional, it's how many tiles would fit on the floor, the walls, the ceiling, how many could you put in the whole thing. But volume, you're absolutely right. Volume is the space in the room. So what I always describe it as, if you know farming, imagine you had bales, right? But you had perfect cube bales, like perfect cubes, hexahedrons, right? And you started stacking them in a room. How many could you fill the room with? It's the air space in the room, right? So, is the measurement of the amount of space enclosed in a solid figure. Now, this is going to be one of the parts of the last thing I'm going to show you today. I'm going to show you the area formulas after a while. That'll be the next slide. I'll go back to that same slide that I gave you the other day when we did area. But I need to give you the formulas for surface area and volume. You need to see the different formulas for the different shapes. So this will, this will have a pyramid formula. This will have a prism formula. This will have a sphere or cone. It's got to have all the different ones that you need to calculate. And they're kind of weird, so I'm going to super zoom in on them and I'm going to have you write them down. When I add them to the website tonight, I'll make sure the picture is really big. And so that you don't have to like squint at the slideshow, you'll have the huge picture of the formulas. Remember, when the slideshow goes on the website, you can just drag the picture, save it, right click and save that slide. So you can always click back, go back to previous ones. It spins automatically, but you can go through it. All right, so here's the formula. So this has surface area and volume. This is the last thing I'd like you to write down today. This is it, no joke. So I'm gonna super zoom in on this, and this is the stuff we're gonna hammer down on Monday. We're gonna do a bunch of examples of these, where I give you a shape like one of those, and we're gonna calculate it. All right. I think everyone had the surface area.
Since we have to wear masks starting Monday, will we have to wear them at our desks?
Yes. So the reason being is that we can't
I thought just in the hallway, because when you can't distance, could we not just spread the desks out?
We might be able to in this class. I could spread you out 6 feet from everyone. We wouldn't have to wear masks. So I can possibly do that Monday. That means I have to switch the seating chart.
That's okay, but that'd be awesome.
Are you okay with me switching the seating chart on you?
Yes.
That would be amazing.
Okay, we'll do that. I'll try to make it like a checkerboard, so that way you can spread. The problem is and you can't tell this in my other classes, like I have a couple classes of 24.
Yeah.
They will not be able to. They will have to wear masks in my room. So,
I don't want to have
so,
to shop.
but yeah, I'll try to spread you out. Eventually, here's the problem. And it's not a problem, it's a good thing, but eventually we're going to have our classmates come back,
Dang it.
right? It's
You're
a
right.
temporary quarantine, right? It's temporary, hopefully, right? Well, the problem is we will have more than just, 6 or 7 of you here. Well, we're not going to be able to spread out like we have, right? We have, 4 or 5 more coming in, so we won't be able to do the checkerboard. So keep that in mind, okay? All right, we ready to go though? Okay, I'm going to super zoom in on this. Does anyone still need that volume definition?
No.
All right, I'm going to super zoom past it. Sorry, we don't need it.
I like being able to zoom in.
Oh yeah, it's awesome. Look at this thing. This is wild. All right. All right. So we got prisms, we got pyramids, we got cylinders, cones, and spheres. So they have all the formulas. Now at the bottom I have the little key for all the letters that you need. So S stands for surface area, P stands for perimeter, volume is V, capital B's are the areas of the base. It represents the area of the base, whatever the base is. H, a little h is height of the object, whatever it is. That's usually from the top of the highest point straight down to wherever that's at. And then L can be a slant and R is radius. So I should just put radius down at the bottom over there. It would have fit. Okay, these are the formulas I'd like you to have written down. Now, I will show you different ways to calculate this stuff. So don't feel like, oh my gosh, I don't know, I'm not going to be able to memorize these formulas. Yeah, I understand. It's going to be one of those things that I will show you a different way to remember how to do it. Now, obviously, I'm going to be filling the board probably this weekend. after you guys leave today from school, I'm gonna start filling the formula board with a bunch of formulas over there for area, volume, perimeter, that type of thing. And I'll probably have to spill over to the other boards as well, so I'll probably put it on the back announcement board as well. So when we take a test, the desk will probably face that direction. I know that seems weird, but it's nice when you have to crank your head around to go see the formulas. I like to turn the desks to face whatever board we need. So we have having 4 marker boards in here.
Just realized you never put it
Again, volume is the airspace in the room. Surface area is an S. So that's how many little square tiles would fit on every surface. The top, bottom, right, left, up, down, whatever you want to call it. So we got some pretty wild formulas here. If you notice, the ones that have pyramids or points like singularities, they have 1/3 in the volumes. That's a way to remember it. They have 1/3. And then if it's a sphere, it's kind of circular. It's got 4/3 on it. That's how I can kind of memorize it. But we're going to look at all this stuff on Monday. You will want the calculator Monday for sure. Now, some of you tend to forget some, but you will want to get a calculator. We're looking at a test by the end of next week in here. The test will be on the names of your shapes, so your polygons, and your formulas for all these polyhedrons and non-polyhedron. So the test will seem significantly smaller than the previous ones, but I promise you it's about 9 to 10 questions again. The vocab takes up the majority of it. I try to break up the units that we do smaller. I call this chapter 2, even though I know the sections in your book are 1.6 and 1.7, 1.8, but I try to break up every unit to be smaller. Can you imagine if we finished out chapter 2 with the stuff we have now? The test would be like 40 questions long. I wouldn't want to do that. We only have 40 minutes in class.
It's a lot to remember.
Yeah, it's a lot. This is a lot to remember, just these 2-3 sections. The worst part is this stuff. I remember taking the ACT in college, or high school, I should say, and then taking MAPS testing and Iowa tests, and they expect you to have these formulas memorized. That boggled my mind. So, I spent a lot of time, trying to memorize these things. And then when you get to college, professors are like, just look it up. Who cares if you memorized it? And if we took a college level math course test, in Calc 2 or 3 or advanced differential equations, these formulas would just be printed at the top. I don't know why we have to memorize them. Especially if you're in a job field that requires it, you probably have it written down somewhere. Or you can just Google it with your smartphone. All right, questions with the volume formulas and whatnot. I'm gonna freeze that on the board. I like the way that thing looks right now, so. All right. But that's it for today. That's honestly all I had. I didn't want to do too much. I want to get you some time to name some objects, to get your formulas written down. It's a Friday, let's take a look.